Today we're going to be talking about writing equations in standard form. If you remember from a couple class periods ahead of today, standard form is ax plus by equal to c. So we're going to write equations that look like this pattern. That's what we're going to be focusing on today. First thing we're going to work on is writing equivalent equations in standard form. So when it says write an equivalent equation, all it would like for you to do is take the equation that it gave you and either multiply or divide every single term in that equation by a constant so that it ends up being an equivalent equation. So for example, this equation here is 2x minus 6y equal to 4. To make an equivalent equation to it, we can multiply by any number. Let's say we multiply everything in that equation by 2. Okay, so we're going to multiply everything in that equation by 2. 2 times 2x is 4x. 2 times negative 6y is minus 12y. And 2 times 4 is 8. So this is what we would call an equivalent equation to the one given in the problem. Additionally, what we could do is we could multiply by a fraction, which would essentially be dividing. So we're going to multiply everything inside this, again, inside the entire equation by 1/2. When I multiply by 1/2, it's like I'm dividing every single term by 2. Okay, so 2x divided by 2 is just x, minus 6y divided by 2 is minus 3y, and 4 divided by 2 is 2. So all three of these equations that have check marks next to them on the notes, those are what we call equivalent equations. Okay, equivalent equations. Take a moment to finish copying down what you've missed on this slide, and then we will keep going. So let's say you are given this equation, which is written in standard form. But as I assume most of you will say, oh no, look, a fraction. Okay? Well, since we can write equivalent equations by multiplying every single term in the equation by a single constant, we can essentially get rid of this fraction by multiplying by the reciprocal. Okay? We're going to multiply by the reciprocal. Reciprocal means that we're going to flip that fraction. Okay, if we flip the fraction, multiplying by the reciprocal, and multiply every single term inside that entire equation, I would get 9 times 1, which is 9, and 1 times 9, which is 9, times x, plus 9 over 1x, y, equal to 9 times 5 is 45, 1 times 1 is 1. So let's just make these fractions look prettier. 9 divided by 9 would just be 1, so I'd have x. 9 divided by 1 is just 9, and 45 divided by 1 is just 45. So these two equations are equivalent because they are multiplied or divided by a single constant. So now we're going to get back to rewriting equations in standard form. Last class we talked about writing equations in point-slope form and then also translating them to standard or to slope-intercept form. Okay, this time we're going to write equations in point-slope and then rewrite them into this standard form. Okay, again remember it's ax plus by equal to c, which means that we want the term with the x and the term with the y on the left-hand side of the equation, and all of the constants combined into the right-hand side of the equation. In this first example, what we would like to do is take this point and a slope and use my point-slope formula and then rewrite my equation. So let's remember what the point-slope formula is. That is y minus y1 equal to m times x minus x1. This is what we talked about last class. We replaced the x and y with the subscripts of 1 and our slope based on the information they gave us. So let's go ahead and do that. I'd have y minus, my y is 2, so I go ahead and put minus 2, remember it's the opposite, equal to 3 times x, and then my y1 is 3, which means I put minus 3 in my equation, again using the opposite. This is currently an equation of this line, but we want to write it in standard form. So we want it to be in the form where x and y are on the left-hand side and the constants are on the right. So first thing we must do is distribute. Okay? First thing we must do is distribute. That means I'm going to take this 3 and I'm going to multiply it by everything inside that parentheses. When I do that, I get y minus 2 unchanged on the left-hand side. 3 times x is 3x, and 3 times negative 1 is negative 9. Okay? The next thing I would like to do, step 2, is to move my variables. Okay, I want to move my variables. I need to get this 3x to the left-hand side so that it can be in standard form. When I move this 3x to the other side, I have to subtract. So I would have minus 3x from both sides plus y minus 2 equal to negative 9. Okay. After I've done that step, let me go ahead and make some room for myself. Okay, I moved the 3x to the other side. I want to move the constants. So step 3 is to move constants. To move the 2, this constant, away from the left-hand side, I have to add 2 to both sides. When I add 2 to both sides, I get minus 3x plus y. The 2's will cancel out there. Negative 9 plus 2 is negative 7. So this is that same equation from up here, now just written in standard form. That's our goal for today, to be able to write these equations from point-slope form here, take them and write them in the pattern like standard form. Here are our 3 steps. Again, we have to distribute the slope. We have to move our variables and take the 3x over here, always doing inverse operations every time. Then I want to move my constants. So in this example, it's going to be the same thing. We want to write an equation in standard form. This time they didn't give me a slope, but that's not a problem because we know how to handle that. When we're not given a slope, we have to find it ourselves. So we set up an x and a y table. We have negative 1 and 1, and then 3 and negative 4. To find my delta y over my delta x, I notice this went down 5, and I notice that this one went up 4. So my slope, or my m, delta y over delta x. Okay, so my slope is negative 5 over 4. I have a slope and I can pick either point. Out of habit, I pick the top one again, and we're just filling in our point-slope equation. Y minus y1 equal to m times x minus x1. We are filling in the x and the y with the subscript as well as the m. We have all of that information. Okay, to fill it in, I say y minus y1. Well, my y1 is 1, so I use minus 1 in my equation. My slope, negative 5 over 4. X minus, well, my x is already negative, so I use plus 1. So here's my equation written in point-slope form. I want to write it in standard form. So I distribute. When I distribute, I'd have y minus 1 equal to negative 5 over 4x minus 5 over 4. Okay, moving my x term, I want to move this whole guy over here. So since it's negative, I have to add. I have to do the inverse. So I add 5 over 4x to both sides, and I'd have 5 over 4x plus y minus 1 equal to negative 5 over 4. Last step is to move my constants. This is my only constant. This is my only constant here. So to move the negative 1 to the other side of the equal sign, I have to add. When I add, I'd have 5 over 4x plus y equal to negative 5 over 4 plus 1. So to add fractions together, okay, all I'd have to do is change this 1 to have a denominator of 4. 4 over 4 is the same as 1. Now I can combine these fractions. Okay, when I do this, And my answer would be 5 over 4x plus y equal to negative 1 over 4. So I don't know about you, but let's avoid some fractions here. This is a correct answer, okay? If you answered like this, that would be correct. But perhaps your answer choices are given in an equivalent equation. If we multiply everything inside this equation by 4, okay, they're reciprocal, I could be left with 5x plus 4y equal to negative 1. That is also the same equation. It is an equivalent equation. It is multiplied by a constant. If this second part, doing the equivalent equation to get to this answer, is confusing to you, but you got here, that is totally fine with me. Keep your answers here. These are correct answers. I'm just giving you an extra step. Next thing we're going to talk about today is called direct variation. We briefly talked about this when we were talking about slope-intercept form. Okay? Equations that are representative of direct variation are of the form y minus equals a times x. Okay, the way this compares to our slope-intercept form, okay, you notice there's no longer one of this, no longer an y-intercept. It's because b is going to be equal to 0. And if you notice that this a just replaces the m to let us know that it's direct variation, a and m for here both mean slope. So let's talk about this some more. So direct variation is a representative of a proportional linear relationship. Basically, it is a line that passes through the origin. Okay, if you have a graph, you can immediately see if it's a proportional linear relationship or direct variation if you notice that the line passes right through the origin. Where's the origin, you ask? Okay, it is the point 0, 0. It's this right here, right where the x and y axis meet. That is my origin. Okay, and if my line passes through there, no matter what the line looks like, this would be what we'd call a direct variation. What you will see in words when you're given a word problem that deals with direct variation is this phrase, y varies directly with x. That's where we get this equation from, y equals a times x. Y varies directly with x. The only thing that's affecting it is this a, okay, where the a is my slope, or the constant of variation. Okay, the constant of variation. Notice again, and it's super important to see, that my y-intercept is 0. Every time my y-intercept is going to be 0. That's very important to see. So let's look at some example problems. Here we have two different equations. One of them is a proportional relationship and one of them is not. If you noticed, this first one does not go through the origin, so this is not a direct variation equation, so this would be not proportional. On the other hand, this equation goes directly through the origin, so this is a proportional relationship. This is proportional, so this would also be a direct variation. Sometimes you'll be given charts and tables instead of graphs, so it's going to be important to be able to recognize a direct variation from a table. Since we're looking for the y-intercept to be 0, we always look where the x is 0. If you have the point 0, 0 on your graph, that means my y-intercept is 0. And so this one would be a direct variation. Now let's say you don't see x equal to 0 on your graph. Instead you see -3, -2, -1. But if you notice, these are going up by 1 each time. So if I added one more, one more slot to here, the next number I would write down would be 0. Okay, we just have to figure out what pattern they're using. If they went from -3 to -2, that's 1. Okay, we got that side. If they went from -5 to -1, how much did they go up or down? Okay, they went up 4 here. If they went from -1 to 3, they also went up 4. So that means if we go up 4 one more time to make that jump to the 0, we'd have that the y-intercept is 7, which means this is not a direct variation. Okay, not direct variation. So if you're not sure about something, whether it be a graph, a chart, an equation, a picture, a situation, some things you can do to check and see if it's direct variation. First thing you can do is make an equation. If you can make an equation and notice that there is no y-intercept, or that it follows the pattern y equals a times x, then you've got a direct variation. Let's say you wrote an equation, but you're still not sure. You have a graphing calculator. Go ahead and graph that thing. And then you can see if it goes through the origin. Something else you can do is find a pattern, just like we did in that last example with the chart. Find a pattern that allows us to see whether or not the y-intercept is 0. Lastly, since these are proportional relationships, you can always set up a proportion to see if they are directly related to each other, if your x's and y's will be on the same side of your proportion. Okay, up next in class you have a packet. You've done your warm-up already. On the back of the warm-up is going to be classwork about putting point slope forms and rewriting them to standard forms, which we've talked about. Additionally, you have a direct variation worksheet. Both of these are due before you leave class today. If you have any questions, please raise your hand or consult a friend. These are two separate grades along with your warm-up that need to be turned in before you leave. Again, if you have any questions, please rewatch the video or raise your hand and ask for help.